It's sitting on top of them.
3, 8, half of 0.75.
Oh, it's going.
Yeah, it's half of 3/4 of a
Yeah,
minute.
it is.
So is it 0.3 to 38?
Yeah.
Yes. 0.375.
75, not to confuse you. Next, 4B.
1.
4B. What is the total height? 2, so I need 1. Agree? What about C? Look at it. We need to go back to the area. You have a circle like this here, half circle. And this is 1 axis. I am measuring tau here, correct? The book is going to give you this distance. Agree? Look, go back to the area table, and what is this when you have half circle? And while somebody is looking on the table,
For C though,
Yeah.
for C it should be 0.375.
what's that?
Negative 0.375.
For C it should be negative 0.375 because it's just the height.
And the y-axis, right?
Yeah.
For C,
Yeah.
on Y, for C is 0.375. D is 0.375. Correct?
Negative.
No,
Both negative.
They're both
It's
negative.
underneath the y-axis.
on Y. This is down underneath Y. This is down underneath Y.
Confusing me about those.
375.375 on both of them. Go to the last one and find the area on. Now we have it like this. Correct? What is your books give you right in here? From the table, the area table in
Whatever.
225.
this one here. What is this here?
So that's that one. So you got the 4R with 3 pi. Yes.
Which ones of these should we memorize for the test?
He's going to give us a
Or are the 3
Oh, you
pi?
said you need this table here?
The table will be provided.
Okay, yes, I thought for some reason.
Is it again 4R over 3 pi is this one here?
Yes.
4R over 3 pi, correct? And the radius in this one is 1.25. 4 times 125 over 3 pi. What is this?
$5.24. Yeah.
How much?
5.24.
No way.
0.53.
0.53?
What? No way. Maybe point five.
The radius,
Yeah, I got 0.53.
0.53.
Yeah.
Wait,
Now-
4R over 3 pi?
4R over 3 pi.
Oh, okay, never mind.
That
That
there
is
too.
5.23.
Now we need to write here
Yep.
2 minus. Agree? Because we need to get somewhere in here. This is all 2 minus. 2 minus. Everybody can see that? Here. We are measuring from here to here. This one here, we know it is 2. So this is 2 minus 0.3.
Yep.
147. Inch, 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 4, inch to 4, inch to 4. Let's look at multiplying. 21 times 0.375 equal
Negative 7.87.
negative 7.87.
Yeah.
Next one, 8. Next one, 471 times 0.375 is
Negative 1.77.
368 times 0.375.
1.38.
And 425 times 147.
3.6.
Negative
Negative.
3.6.
3.6.
Now look at positive and negative in this. Which is positive, which is negative, and why?
Well, 1.38 becomes positive because there's two negatives.
Yes, because you are deducting the x-axis. Let me come in here and show you what we do in here. This is the y, correct? But the x and z are up here. Can you see that? In this situation, everything is here need to be deducted. However, the empty hole here, this circle, negative, negative, that's why it's going to be like adding it. Make sense? Let's go to the last one, which it is the z direction. On z direction, we are measuring from x. For the very first one is, give me a number. 247, 3.5. Agree? Everybody?
Yes.
Element B
2.
is giving 2. Element C. Element C is going to be 3, 2, and 2, 7. Plus 4 are 3 pi. Agree on this?
I think it'd be, oh yeah, 7 plus. Yeah.
You are measuring here from this. This distance here is 4 r over 3 pi from your chart.
Where is that?
And we need to add it to the 2 and 2 and 3. 7.
Which is 7.85. 7.53.
7.35.
85.
85. Element D, 7. Agree? And element E is 2. Let's now go to C, multiplication. 21 times the 3.5 is
73.5.
73.5. 16. 2 times 8 is 16. 471 times 785 is
36.97.
36.97. Negative 368 times 7, 24 something.
25.7, negative 25.76.
And 2, 4.9.
Negative 4.9.
Give me the summation, please. And summation here. Summation and summation.
I got negative 3.86 for the sum of the yi times bi.
Negative
Yes.
3.
3.86. And I have 95.81.
Yeah.
Okay. Now, let's look at let's look at x bar equal sum of xi vi over sum of vi, which equal vi total is 27.6. xi vi is 46.8. What is this?
1.6.
How much?
1.7
1.7.
inches.
Let's look at y bar. yi vi over v total, 27.6, and this is y negative 386.
Negative 0.14.
How much?
Negative 0.14.
And z bar $95.81.
3.47.
3.47.
47.
So let's put now the centroids on their location. On x, I have 1.7. So on x, from here to here, I need to come with 1.7. This is the 2. This line here is the 2, correct? 1.7 is somewhere in here. Correct? This is x bar equal 1.7. Y. Y is negative underneath by something very little somewhere in here. So this distance here is y bar that equal 0.14, correct? Z is coming this way. Z is coming this way, z bar. 3.5 almost. This is 7.
About halfway.
4 somewhere in here. 3.47. They meet underneath this point here by what point? 0.14 underneath the surface. So if you look at your book and look at this plate, so we are meeting somewhere underneath this cover here. And the 3 in one direction, 3.5, 1 point something in other direction. Is this clear?
Well, it should be that pretty much from any solid object. It should be somewhere in the middle of it. Yes.
No, but this is because it has this one in here shifted from half of it 2 and 2 to this way.
Right, I know, I just mean that it should be somewhere within the y direction,
Yeah.
within the actual object.
Exactly. Questions on the volume?
No, no.
Could have an object shaped like this.
Questions?
It's shaped like a
Yeah,
wedge
no,
or
I know.
something.
The same question.
Questions on the volume? Okay. We are now going to move to distributive forces. Usually, in real life, there are nothing called concentrated forces, very little, which it is generally the cables. Any cable, whatever you see a cable, a rope, holding rope, that is the only concentrated forces. Everything else is distributed forces. So, in generally, here is a beam, and this beam is loaded whatever above it. So what we are looking for, each one of this is Wi, 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 if you want. If I add these Wi's, I get the total weight. So I can divide it into 500,000 little stuff, particles, whatever you want to call it, and fine. So In real life, if I look at this as this is y-axis, and call these W1, W2, W3, W4, Wi, Wn, like this. Then this one has x1, this one has x2, this one has x3, this one has xi, this one has xn. Agree? Now, if on the other hand, this is the beam here with this load. If I can find the weight of this load somewhere in here, W total. This W total at x bar. Agree? Let's look at the moment on y, or moment on y-axis. The moment here on y-axis is going to be W1 times x1, W2 times x2, W3 times x3. Positive, positive. You want to call it negative, negative, negative. Wn xn. Agree on this? What about the moment on y-axis from this one? Moment on y-axis, negative W x bar. Agree? Or x bar, if this is equal, this is supposed to give you the same moment, whether you deal with it as one unit or you break it down into small pieces, correct? In this case, the Wx bar equal Wx1, Wx2, Wx3, and so on, Wxn. Or double x bar equal Wxi sum over W. This is what we have been doing in the past. So when we deal with forces, we need, when we look at any shape, we need to divide this shape according to what we have in hand. What shapes we have in our book, what shapes we have in our tables, and divide this into small portions for which we can start working with W's separately times X's or Y's separately according to the information that we can collect from the table. Break or no break? Come on.
Yes.
Right, yes.
Okay, go take a break 10 minutes and come back.